Hi, this is Mrs. Clark, and welcome to my video on angle of elevation examples. We're going to actually go through 4 examples of elevation and 4 examples of depression. You'll notice on each of these 8 examples, pictures are drawn for you, so we're going to focus on labeling the information on the diagram, and then you're going to set up the equation, we're going to solve it. The actual skills of solving them should be a review of the things we've already learned. We're not learning any new skills here, we're just applying the skills that we already have to these word problems. So number 1, a hiker is standing 220 feet from the base of a hill. The angle of elevation from where he is standing to the top of the hill is 29 degrees. How tall is the hill? So usually I have to read a word problem twice, first to kind of get an idea of what's happening, and then second to look for the specifics. I do want to point out, in case you can't see it, that there is a little dotted line drawn down this blob here with a right angle at the bottom. So if we're looking for a triangle, there, that kind of completes the triangle. So over here we have our hiker. This is our hill. And it says a hiker is standing 220 feet from the base of a hill. So if this is the hiker and this is the hill, the 220 is the direct distance between the two of them, which is the leg at the bottom of this right triangle. Then it says, next, the angle of elevation from where he is standing, so that's over here, to the top of the hill. So here's the line of sight. So coming off of the horizontal and going up, this is our angle of elevation is 29 degrees. So I'm going to fill that in. How tall is the hill? Well, that's asking for the height of the hill. So I'm looking for from ground to the top, how tall is this? So this is my x. This is what I'm looking for. So I got to figure out what trig function I'm going to use. Based on this 29 degree angle, the x is my opposite, and the 220 is my adjacent. So if I'm thinking of SOHCAHTOA, opposite and adjacent is tangent, so I'm going to use tangent of 29, because that's my angle, over 1 equals opposite over adjacent, so x over 220. To solve this, next I have to cross multiply. This is the step that quite a few people are leaving out. When I cross multiply, I multiply x times 1, and I get x, so I'm going to write that, equals, then I have to cross multiply in the other direction as well. So if I do that, I have to multiply tangent of 29 times 220. And those two things are going to be equal. Those are called the cross products. So the purple, whatever I get when I multiply the purple, will be equal to whatever I get when I multiply the pink. So x times 1 is just x, or 1x. Tan 29 is a number, and it's going to be multiplied times 220. So I'm just going to write here tangent of 29 times 220. And I'm not going to use an x for times, I'm going to use a dot because that's going to get confusing with this x. So if I want to know what x is, I have to multiply tangent of 29 times 220. We know how to do this in the calculator. So I'm going to grab my calculator. Tangent 29, close my parentheses, times 220. So 121.94799. It doesn't give us a direction on how many decimal point places to use, so we'll use 2 because that's our default rule. So 129.95, the 7 will make the 4 round up. So x is approximately 121.95 feet. Feet? Yes, feet. I do want to point something out real quick. Please make sure that you're closing the parenthesis after your tangent of 29. If I don't close it, and I just do the times 220, you'll notice we get a very different answer. So the calculator is doing 29 times 220 and then taking the tangent of that. So make sure you close the parenthesis after your 29, so the calculator knows you're done entering your degree, and then it can multiply by 220. Alright, so here's our final answer. The hill is 121.95 feet tall. Alright, on to number 2. A 30-foot ladder forms an angle of 50 degrees with the ground when placed against a brick wall. So a 30-foot ladder This is the ladder. This is going to be 30 feet. It forms an angle of 50 degrees with the ground. So that means from here to here is our 50 degrees. When it's placed against a brick wall. How far up the wall will the ladder reach? So we're looking for this measurement from here to here. So we're looking for this is our X, or if you want to label it on the triangle, it's this leg in the triangle, either way. And then it asks the second question and says, how far away from the base of the wall is the ladder? They also want to know if the bottom of the ladder is here and this is the wall, how far away is it? So we actually have to find two things in this one. So we got to find X and we got to find Y. So what I'm going to do is I'm going to set up a trig function to help me find X. I can set up a different trig function to help me find Y. So let's do that together. First, based on the 50, I want to label, use a different color here, the sides. So I have the opposite leg would be X, the adjacent leg would be Y, and the 30 feet would be our hypotenuse. I just want that to stand out for a second because when we go to pick our trig functions, I want you to be able to see that. So if I'm basing it off the 50-degree angle, if I want to find X, I don't know X and I don't know Y, so I'm not going to use this side right now. That means I'm forced to use opposite and hypotenuse, which means I'm going to be using, if you look at SOHCAHTOA up here, opposite and hypotenuse, so sine. To find X, I'm going to use the sine. So what is it sine of? It's sine of 50 over 1 equals opposite over hypotenuse, X over 30. We're going to solve this to get X, then we're going to come back and set up a different equation to find Y. So if I cross multiply, just like we did on the last one, X times 1 is X, and that's going to be equal to sine of 50 times 30. So I'll just need my calculator quickly to do sine of 50 times 30. And X will be approximately equal to 50 times 30, 22.98 feet. Now, to find Y, let's cover up the X. Oh, hold on, I'll do it this way. And I want the adjacent side, and I have the hypotenuse, so now I'm going to be looking at cosine. So if I do cosine of 50, it's going to equal Y over 30. So if I'm looking at a different side, but still from the same angle, I can use a different trig function to find a different side. Still cross multiplying, Y times 1 is Y. Cosine 50 times 30, I'm going to write that down. So Y is going to equal cosine 50 times 30, which is 19.28. So Y is approximately 19.28 feet. Now, there's lots of different ways I could have found Y. I didn't have to use cosine. I could have found Y by using the answer I got for X and using tangent. If I didn't need to use trig, or practicing using trig with these, I could also have done Pythagorean theorem with our hypotenuse and the X value that I just got to figure out Y. Since we're focusing on practicing trig with these word problems, we're going to do them using trig, but that's just to let you know there are a few options. Also, ways that you can check your work if you are unsure. So sometimes if you know another way to do the problem, then you can check your work easily. All right, if you are ready, you might want to pause quickly, try to set this one up yourself, and then check back to see if you did it correctly. All right, Alex is standing on the ground and looks up to see a plane flying in the sky. If it is flying at an altitude of 2 miles, and the distance along the ground is 5 miles to a point directly below the plane, what's the angle of elevation that Alex has to look up? All right, so we got it's altitude of 2 miles. So I mean, from the plane down is 2 miles. The distance along the ground is 5 miles to the point directly below the plane. So from Alex, who's over here, to the point directly below the plane is 5 miles. And we want to know what is the angle of elevation. So that's this angle here. We're looking for theta. So if we're looking for theta, we've got to figure out what trig function we need. This is our opposite side. This is our adjacent side. We don't have the hypotenuse at all. This is our right angle. So we want to use tangent. So we're going to set up our equation. Tangent of theta, this time our variable is the angle, so tangent of theta, no number here, is going to equal opposite over adjacent, so 2 over 5. The last skill that we learned how to solve for was solving for a missing angle. And so when we did that, we learned to use the inverse of sine, cosine, and tangent. So if you look at this equation, in order to remove the tangent from the theta, I have to get it off. So if this was like a 2x, you would divide by 2. I can't just divide by tangent because tangent always needs an angle with it. So the only way to get it off of the angle is to do what's called the inverse operation, or tan inverse. So tan inverse looks like this. It's basically tan negative 1 is what it looks like, the negative 1 in the exponent. And what we're going to do is we're going to take the tan inverse of both sides of the equation. So let me show you how it's going to look. I'm going to write tan inverse on both sides of my equation. And then I'm going to fill in exactly what each equation had. So the equal sign was here. The left side was tan theta, so I'm going to put that in this parenthesis. And the right side was 2/5, so I'm going to put that in this parenthesis. And the reason I did that is when I take the tan inverse of tangent, those basically undo each other. So this and this will cross off, and I'll be left with just my theta. And that's going to equal whatever tan inverse of 2/5 is. I just need to put that in the calculator. So if I pick up my calculator, I can remind you how to type this in, but this is all going to just go in the calculator. Okay, so how does that go in? Well, grab my calculator. To find tan inverse, if you look behind the tan button, there's a tan negative 1 in blue, so I just hit the blue button and then tangent. That gives me tan inverse. And then I have tan inverse of 2/5, so just 2 divided by 5 is 2/5. And hit enter. So it's 21.80 degrees. So the angle that he's looking up at is 21.80 degrees. So approximately 21.80 degrees. That's our final answer. All right, pause for a minute, try to do the last one, and then check back in to see if you did it correctly. All right, Michael, whose eyes are 5 feet off the ground, so this distance from his eyes to the ground is 5 feet, is standing 30 feet away from the base of a building. So his feet are 30 feet from the base of the building, so that's this. And is looking up at a 50-degree angle of elevation. So this angle here from the horizontal to his line of sight is 50 degrees. And he's looking to a point on the edge of the building's roof. To the nearest foot, so we got to round our answer to a whole number. How tall is the building? So the building is this tall. Whatever that is what I need my final answer to be. So how do I take what I have so far and figure that out? Well, if the height from his eyeball to the ground over here is 5, then it's the same thing on this side because that's just a rectangle at the bottom. And if this, in fact, is a rectangle here, that means that this leg of the right triangle is also 30 feet at the top. Now, why do I care about the 5? Well, if I can find this leg of the right triangle, if I can find this leg, so if that's x, I can add it to the 5, and that will give me the whole height of the building. And that will tell me how tall the building is. So if I focus on the triangle that is up here, and outline it here in purple, and I can solve for x, I can use my answer for x to help me find the height of the building. So this is the opposite side, this is the adjacent side. I want tangent. So tangent of 50 is going to equal x over 30. We're going to cross multiply. X times 1 is x. It's going to be equal to tangent of 50 times 30. And then I'm going to put that in my calculator. Tangent of 50 times 30. And I get 35.75. And it says to the nearest foot, so I can round this to the nearest whole number. So is it closer to 35 or closer to 36? Because it's a 0.7, it's closer to 36. So I'm going to say x is approximately 36 feet. But I want to know how tall the building is. So I'm going to have to take this 36 feet and add 5 to it. And get 41. So the building is 41 feet tall. And there you have it. All right, we're going to do the angle of depression examples next. So grab that paper. I'm going to go through these a little bit faster because now we've kind of done our review of how to solve and set up the proportions. Feel free to pause it if you need to, if I'm going a little too fast. But you'll learn a little bit how angle of depression examples can be slightly different than angle of elevation. So a little boy is standing on a cliff above the water and sees a boat that is 200 feet away from the base of the cliff. It is 315 feet away from him. What is the angle of depression from him to the boat? So here's the little boy. Here's the boat. This is the cliff. And so I noticed the question is, what is the angle of depression? So if I remember, an angle of depression is always based off of the horizontal and the line of sight, which would be looking down. So our angle of depression is here, and that's what I'm looking for, so I'm going to put a theta in there. Now let's go through the rest of the information that they gave us. It says he sees a boat that is 200 feet away from the base of the cliff. So if here's the boat, and imagine this is the water, right? This boat is 200 feet from the cliff, so that's going to be this direction. And it also says that the boat, it is 315 feet away from him. So here's the boy, here's the boat. How far away are they? This straight line, so that's my diagonal line here, is 315 feet. Now, notice I have a right triangle over here with 315 and 200, but I have theta is up here and outside of that triangle. So I may have to use that idea that we talked about with the rectangle and see if I can transfer any of these measurements onto this purple triangle that I have highlighted here. So if you think of the overall shape from the cliff across the water up and over, this makes a rectangle. So if there's 200 feet down here, there's also 200 feet up here. I can transfer this 200 feet up here. Now I have 200 on this leg. I don't know this leg, but I know the hypotenuse is 315, and I'm looking for that angle. So I have two sides. If I want to find the angle, I just have to set up my equation, figuring out which trig function to use. So if I look at which sides I have, this would be opposite, so I don't have that one, which means this is adjacent, and this is hypotenuse. So if I'm using adjacent and hypotenuse, that would be cosine. So cosine of theta is going to equal 200 over 315. To solve it, we're going to use inverse of cosine. So cosine inverse of cosine theta is equal to cosine inverse of 200 over 315. These cancel out. Theta is approximately equal to whatever cosine inverse of 200 over 315 is. So we get 50.59 degrees. So you're going to have to use this rectangle idea sometimes when you're given certain measurements, but they're outside of the triangle that you're really focused on, to know that the opposite sides are equal in this way too. So look for multiple triangles in your picture to help you out. All right, number 6. A princess is on top of a 167-foot tower looking down at a 37-degree angle of depression at a package attached to a rope on the ground. How long is the rope? So if I'm looking at her here, this package is attached to a rope. I'm guessing this is the rope from here to here. She is standing on a 167-foot tower, so that's this. She's got an angle of depression of 37 degrees, so that's here. This is sort of forming a right triangle here. I've got the hypotenuse that I'm looking for, but this 167 is going to go over here. So I've got my opposite side and my hypotenuse, so that's sine. So sine of 37 is going to equal 167 over x. So when I cross multiply, we haven't done one like this yet in our review here. 167 times 1 is 167. That's going to be equal to sine of 37 times x. And so in order to get the x by itself, it's not x equals, it's x times sine of 37 equals. Well, to undo times sine of 37, I'm going to divide by sine of 37, just like if it was a regular coefficient of x. Those are going to cancel out. I'm going to do the same thing on the other side of the equation, under the 167. And then I'm going to put this in my calculator. So 167 divided by sine of 37 is 277.49. So x is approximately equal to 277.49 feet. If you want to pause and try this one on your own, that would be great. And then check back to see if you did it correctly. From an airplane at an altitude of 1,200 meters, so that's a height. The angle of depression to a building on the ground measures 28 degrees. So that's from the horizontal down, is 28 degrees. Find the distance from the plane to the base of the building. So from the plane to the base of the building is this diagonal distance. So that's our x. Now if I try to make a right triangle here, I'm missing information, so I'm going to actually do it here where my angle is. And I'm going to remember that if this is a rectangle, 1200 goes here and 1200 also goes here. So focusing on the top triangle, 1200 is opposite my 28, and I'm looking for my hypotenuse, so it's sine. So I'm going to do sine of 28 over 1 equals 1200 over x. I'm going to cross multiply. 1 times 1200 is 1200. Sine of 28 times x goes on the other side. So if I divide those out, x is approximately equal to whatever 1,200 divided by sine 28, and that is 2,556.07, and that's meters. All right, one more to go. Sonar operator on a battleship detects a submarine at a distance of 500 meters horizontally and at an angle of depression of 37 degrees. How deep is the sub? So, how deep is the sub would mean how far from the surface of the water is it down? So that's this measurement. An angle of depression of 37 degrees is going to be here. The distance from the submarine to the battleship, submarine is this down here, battleship up here. Horizontally is 500 meters, so that's this direction. And we are looking for how deep the sub is, so that's our x. So to find x, we're going to need opposite over adjacent. We're going to need tangent. So tangent of 37 over 1 is going to equal x over 500. Cross multiply, x times 1 is x. It's going to equal tan of 37 times 500. So x is going to be approximately 376.78 meters. So that's how deep the sub is, about 376.78 meters. And there you have it. There's your angle of depression examples. So glue these into your notebook. Then you're going to work on some practice problems. You're going to practice by drawing out the pictures yourself. Like I said, you can feel free to add little things like this, like a very simplistic boat if you want. A stick figure for a person works really well. It's pretty easy to draw buildings, ladders, things like that. Anything that you can do to help create a picture that represents the situation. Thank you for watching.